Hello, welcome to Chapter 3, Three Claims, Four Validities. This is where we begin to learn how to examine studies with a critical eye, to use certain tools and ways of thinking and approaching our reading of studies to get a sense of the quality of any given piece of research. Now, whenever we read a research report, we have to recognize that it should be making some kind of claim in it. And therefore, we have to examine whether or not the claim is being supported well. Reasonably, a research report should not only make the claim, but also support the claim, provide evidence of the validity of that claim. By interrogation, this is a unique word used by the author in the context, but I think it's a good one, is describing the intention to determine what we can judge about the claim, making judgments about the claim by interrogating the elements of validity that may apply to any number of aspects of the study. By interrogation, we're going to make critical queries to try to gain insight into the issues of validity. Every claim needs certain validities to be robustly based so that the claim is supported. And as we learn over time, we get a sense of some studies are well done and some not so well done, and the claims are either very robustly supported or somewhat weakly supported. One of the things we have to first get ourselves acquainted with if we're going to begin examining these kinds of questions is the concept of the variable. Now, you are familiar with this from some other classes without a doubt. Of course, it means something that varies. Now, we have to get used to a couple of different terms that may not have shown up in your other classes. Almost certainly you've talked about variables taking on values in other classes you've taken. But in our research in the social sciences, we sometimes also refer to these values as levels, not just values. And the reason for that is manipulation that occurs in our studies often is best described with that kind of term rather than value, because there may or may not be a specific numerical characteristic to it. Variables can be measured or they may be manipulated, and we're going to talk about aspects of both of those things. Measured variables are, well, just what it sounds like. You've made an observation and you've measured it. There's a certain height, speed, weight, degree of narcissism that you see evidence of. And sometimes the measurement is very precise and very easy to get a hold of when we're talking about something like height or weight. Sometimes it's more difficult to get a hold of, such as degree of narcissism. In any case, a measured variable is simply that, recorded based on our observation system. That observation system is important, as we'll see in a few moments. We can be any kinds of things, not just these things that might have some kind of quantity attached to them, like height or speed or weight. It could be something where we're simply classifying things into types that are associated with the variable. Our variable could be car type, and it could have levels of sedan, SUV, sports car, and so forth. It could be gender, it could be age, and these are all measured because they're probably not assigned by the researcher. And this concept of assignment by the researcher takes us to the idea of a manipulated variable. That is, a variable that is controlled by the researcher, assigned by the researcher to be a situation or an experience that participants in our studies may have applied to them. This being controlled by the researcher is key because that's the essence of the manipulated variable. I may assign someone to the type of car they drive in a simulator. Earlier I described car type as something I might observe, but it could also be a manipulated variable. Excuse me. I might assign people to have words pass by faster or slower in a reading test, so the speeds of words passing by the person in the reading test could be a manipulated variable. Could be the degree of anxiety that I could create in a participant also, or the amount of medication given, or the type of classroom that the instruction is done, that we do instruction in, and so forth and so on. In all these cases, you have a variable. That is, the concept that can take on many different values. And you have levels, the amount or specific type of the variable that you're observing. Knowing the difference between a variable and levels of a variable is key to making good grade in this course. I strongly recommend, if you do not understand the distinction between a variable that has a name and its levels that have further names that are basically instances of the variable concept, then you need to come talk with the instructor and get some clarity on this, because it is an essential concept for understanding the material in this class. From concept to operation, what we mean is to recognize that our theories operate at the level of concepts, describing the relationships between conceptual variables. What's the relationship between attraction and friendship? These are relatively vague notions. I mean, we believe there's a relationship there, but how are you going to measure them? And then that means, what's our hypothesis going to be? To test a hypothesis that's about attraction and friendship, we have to operationalize the variables. We have to turn them into specific and concrete measuring methods, or concrete and specific manipulations. Maybe we've got a concept called academic success, and we might want to measure this as some kind of thing I observe about students in college. I might find out or inquire of the student what their grade was in a specific class. I might find in their transcript or ask the student to report their GPA in a given semester or at graduation. I might evaluate the status of their graduation at the end of the fourth year in school. Have they graduated or not? That in and of itself could be a measure of academic success, a simple yes, no. And we might give some kind of grade based upon a standard exam of achievement, things we expect a student to learn in college. I could also have academic success be a manipulated variable. Now this might surprise you a little bit, but almost anything can be made into a manipulated variable in the correct study. For instance, for academic success, it may give a person a bogus grade assignment on work that they do. I may say it was A-level work. I may say it's C-level work. It doesn't really matter. I didn't actually examine it. It's a bogus grade determined from a random table. And what I'm trying to determine is, how does this feedback affect their self-esteem, the person's self-esteem? Or it could be something else I'm trying to learn about. Maybe it's how it affects their motivation on a subsequent task. There's any number of studies that could be done where the first manipulation is some measure of success in an academic kind of environment. It could also be part of a description of a student in a story. I could say that the student has a high or a low GPA, and I want to see how that changes the perception of that student by persons reading the story. Maybe it's a story about a student who plagiarizes. We're trying to determine about how people perceive the culpability of the person in the story. Do they seem more or less likely to be guilty based upon a simple manipulation of how academically successful the student appears to be? So what we're talking about whenever a research study is done is a claim, and we have classified them into three types of claims. A claim is something that we might describe as an argument that we're trying to make about the nature of the world, how the world looks or how the world works, that kind of thing. A frequency claim is simply a statement of how much or how often something is observed. An association claim is a claim about a relationship between variables. Certain levels of one variable are more associated with certain levels of another variable. Also, there's causal claims. One variable is responsible for what happens, what is observed to occur in another variable. And so we can have frequency claims, association claims, and causal claims. Let's talk a little bit more about each of these. A frequency claim is just noting that a relative amount of something or frequency of observing something has been made. It's a simple claim and it relies only on systematic observation and recording of data. I might say something like 3% of the U.S. population has a PhD degree. One would presume that I've done appropriate ways of measuring these things to say make this statement. In fact, that becomes the essential thing we end up examining the validity of. We might say children 2 to 5-year-olds watch an average of 4.6 hours of television per day. We might say people born in 1994 have an expected lifespan of 81 years. All of those would be fundamental claims about the relative amount or frequency of observing something. Association claims are claims where we're trying to determine if there's a relationship between at least two variables. We're trying to show that when one variable changes, another variable systematically changes also. The percent of persons with PhD has increased from 1 to 3% over the last decade. Watching more TV as a 5-year-old is associated with greater weight as a 30-year-old. Lifespan is related to gender. For women born in 1994, the expected lifespan is 83 years. For men, it is 79 years. All these are saying, excuse me, is that there's some relationship between one measured variable and some other observed variable. So we see percent of persons varying with time. We see amount of television watched as being associated with weight at a later point in life. And we see that depending on your male or female, lifespan may be different. Now, causal claims are our most sophisticated claim we want to make. That we are trying to say that one variable's changes are responsible for changes in another variable. We want to show that other factors may not explain the change caused by one variable on another. There could be some intermediate variable that is, that adjusts, increases, or decreases the connection, but the connection is something we expect to observe. For instance, making loans more readily available increases the likelihood that someone will pursue a PhD. Restricting a child to only 2 hours of TV causes a drop in their weight. Playing bridge causes improved cognitive functioning and longer lives. All of these are causal claims. What we're trying to say is that some variable that we're observing depends upon its changes are the responsibility of its connection to some other variable. So we have these three claims, and all of them have various characteristics that we can begin to investigate, characteristics of validity and how these claims are argued and supported in a paper. And these support points are what we call validities, the things that build the validity of a paper. We need to assess and interrogate the validity of claims. And there are four main types of validity that can be used to do this. There is construct validity. Basically, it's how well we've measured things. There is statistical validity, how well we've analyzed things. There is internal validity, how logically we have built a case for excluding any alternative explanation for a causal relationship. And external validity, the degree to which the statement we're making can be said to be true not only of the people we directly measured, but of other people besides those we measured. Does it apply to other people and other situations? A construct is the conceptual variable that is under investigation, the theoretical notion. How we go about measuring it is the operationalization. And what we're interrogating is the operational interrogation to determine if it has construct validity, that it represents the construct well, or at least we know the limits of it. To what degree does the operationalization fit that conceptual construct? and it leads to certain limitations on interpretation often. It is most crucial for frequency claims. If I make a statement that 75% of children suffer child abuse, well, the first thing that hits me is that's a huge percentage, and I want to know, how did they measure child abuse? If they asked children questions about how they were treated and included a question such as, have your parents ever yelled at you? And a yes answer was considered evidence of abuse, I think that tends to suggest all of us, or a large portion of us, have been guilty of child abuse. Because in all of our studies we are measuring and manipulating variables, construct validity is always something to examine in a study. An association claim may fall apart or become stronger or weaker if the operationalization is changed. Similarly, a causal claim may change if the operationalization is changed. So you have to look at how the variable was measured to determine if everything else about it. If you don't have good measurements, you really don't have much else for your study. Statistical validity is about the application of statistical methods and analysis to the data. Margin of error is kind of a fundamental issue here. All measurement has error inherent in it. It's related to variability in the data and sample size. For frequency claims, it's pretty much all you have to look at. The nature of the frequency claim is to give some sense of an expected amount of occurrence. And so margin of error is giving us some sense of the certainty about that amount. I think we're all familiar with political polling and how very, very, very often the political polls will have a plus or minus 3% number attached to them. So the poll may say something, currently President Obama's favorability rating is 38%. And then after that it says plus or minus 3% margin of error. And basically what it's saying is 38% is where our number's calculated, but our methods tell us that it could be as high as 38 plus 3% or as low as 38 minus 3%. Now there's more to it than simply that, but that captures the notion pretty well. It says it's about here, give or take a little. And that give or take a little obviously can be very important. For association claims, both of the variables have margins of error. So you can see that could have a big effect on interpretation. You got not just one variable with a margin of error, but two. And you want to be confident the correct degree of association is measured. And this is shown by something we call effect size and another thing called statistical significance, which is a test of if the association is genuinely there or simply the kind of random noise that happens with all data collection. For these claims, there's concerns about making what is called a type 1 error. A type 1 error is a claim that there's a relationship between variables when none is actually there to be found, that the relationship doesn't actually exist. Yet because of the fact that all measurement has noise in it, that noise can kind of, in variability that you're not accounting for, what we call error, you can't help but occasionally have them conspire to make it look like there is an association when really there's not one. We just had an unfortunate roll of the statistical dice. Internal validity describes the degree to which you can make a claim that's causality can be established between the variables, that one variable is responsible for the changes in another variable. It is unimportant in frequency claims and in association claims, though concerns that other factors may explain an association should be acknowledged and, if possible, controlled for association claims. External validity is the degree to which you can be confident that the findings of a study extend to others, other people, and other situations who are not measured. This is mostly about sampling. You want representative samples, and you want to be careful that your situation is not too terribly unusual or unique. For frequency claims, external validity is critical. For claims of association and causality, it is useful and valued, but not as critical to be able to make a fundamental statement of association or causality. For instance, we found in our classes students who had computers open did worse on lecture quizzes. That statement is just about your class, and therefore its external validity. You're not trying to make a statement beyond that. And you're acknowledging, kind of implicit in the statement, students in our class, that you're not trying to say it says anything about students in other classes. On the other hand, you may say, we find that college students who had computers open did worst on lecture quizzes. Now, this is a statement that is stronger. It's trying to make a statement of we know something about how other college students beyond the ones we measured did. That means you have to really be assured that the students you measured are representative of other students, that they resemble them in key ways. So we have to have good external validity to make that second claim that's indicated here. Let's return back to causal claims a little bit, because there's really critical things to make sure we understand here. This is our goal. We want to be able to show what causes what. To make a causal claim, we need three things to be true. 1, covariance. We need to find an association between variables. We need all the things in place we need for a good association claim to be able to start down the road of making a causal claim. We need what's called temporal precedence. We need to have an assurance that one variable precedes the other in time. So one thing can only cause another thing if it precedes it in time. And internal validity. Alternative explanations can be ruled out as explaining the measured association. Now notice that external validity is not important for making a causal claim. It's important for making a causal claim that you say applies to a large number of other people, but for the fundamental statement of a causal claim being made, it's not necessary. Getting at internal validity is usually done by designing what we call an experiment. We want to do it well. We want to do a well-designed experiment. Sometimes we call this a true experiment. In such a case, we have an independent variable. That's the variable that we're manipulating as researchers. And we have a dependent variable. That's the variable that's measured as the outcome in the experiment, the measure of what the participants in the study produce. Temporal precedence is handled because the manipulation, the independent variable, ensures it's the first thing that happens, or it happens before you do the measurement of the other variable, before presumably, usually, the participants have had a chance to respond. Internal validity means that all the possible reasons that the outcome variable may differ from one group to the other can only be reliably attributed to the manipulation. Alternative explanations are either irrational or impossible. For instance, if I test students on two different ways of learning material, a video demonstration or a verbal description, and show that that demonstration works better, there are alternative explanations that may apply. For instance, the time of day. If one group was measured it in the morning and the other group in the afternoon, they could be differing. The rooms could be different. I may have had to one class and one group in one room and another group in another room, and the rooms may differ in ways that could matter to their learning. You could have different presenters. You could have different participants in the conditions. Some of these are easy to handle. The different rooms, time, and presenters, you can just simply make sure that you do things at the same time, you do things in the same rooms, you use the same presenters, you make sure you use the same stimuli in any of these cases, all that kind of stuff. Those are relatively easy to handle. One of them's harder. The different participants. They're going to be different participants in most studies that we design. So since they're going to be different, does the different participants, does that end up becoming an alternative explanation? And if so, how do you deal with it? How do you make it so it can't be a reasonable, a rational alternative explanation? Maybe the participants were ones that picked a preferred way to learn. They had a choice. I can pick to be in the visual learning or in the verbal learning group. Are there folks that tend to do better early in the day, and they pick being in one condition, and folks that feel that maybe the folks that show up early tend to do better, and you filled one room with the early folks and then you filled the other room with the late folks. I mean, these are all kinds of things that could end up being an alternative explanation because they're different people based upon other factors that may or may not be related to our outcome variable. For a lot of these things, random assignment is the solution. Randomly assigning people to conditions means that any differences amongst them are spread out evenly. Saying it again, random assignment to conditions means any differences are spread out evenly. That is to say, maybe you've got persons that just have better GPAs show up and end up all in one room because that's what they wanted to do. They wanted to schedule that room. Well, that could be an alternative explanation. But if I randomly assign people, I can be assured that any GPA persons that are high are distributed evenly in the low in one room, one condition, and the other condition. Persons with lower GPAs are also randomly assigned to be in one of the conditions or the other condition. But still, we have to remember in the back of our mind that random assignment is a rational approach, and it makes an argument against the validity of the study irrational. It's not a guarantee. It's possible that the groups differ in ways that matter. But the chances of that are small, usually very small. So we live with the risk of knowing that our groups may be different because random assignment simply failed us. But we still are on our best ground to assume it will succeed, because in the end we have to do that because we don't have many other better ways of handling it. There are a few techniques, but they're kind of advanced and beyond the scope of this class. So in closing, we've learned about 3 possible claims and 4 validities that help us to evaluate the claims. One of the key things to learn about all this is there's no such thing as a perfect study. Some studies are better than others based upon evaluating validities. What we're looking for is a degree of support. How good is it? Is it great? Is it good? Is it okay? Is it I don't buy it? And every study falls somewhere along these lines in terms of an examination of its validity. Usually we expect to see the I don't buy it studies to not get published, the so-called, and sometimes that's the correct decision for them. On some occasions it's not the correct decision. They should have been published. They ran into reviewers that were unimpressed for one reason or another, that maybe they were biased in some way against the study. That kind of thing does happen. Whatever the claim is, there should be evidence presented in the article to justify it based upon an examination of the issues of validity we've been talking about. What we're going to be doing later in the class is talking about these validities more and more. It's the core of this class is talking about validity. And so we're going to be talking about what are the various things that threaten the validities we're talking about, and how can we deal with them. I want to thank you for your attention, and I'll see you next time.